The universe is filled with countless other worlds. Among the thousands of exoplanets discovered outside our solar system, so far none can be considered more hospitable to us than the Earth. Some of them are melted by the unbearable heat, close luminaries. Others are forever frozen in ice or scorched by deadly radiation. However, among the many inhospitable worlds there are also completely different ones. Oceans splash and rivers flow on their surface. Clouds float across the sky and showers and rain rage in the atmosphere. Thunderstorms. Perhaps these worlds can become a cradle for a beautiful and unique life as once happened with the Earth. And today we will go to the most remarkable of them. It is hard to argue with that life is one of the most amazing, complex, and mysterious phenomena in the universe. Even though we have been studying it for thousands of years, many important questions related to it still remain unanswered. And the most important of them, how widespread is biological life beyond our planet? At the moment, we are still that we can't say with certainty, is the Earth's biosphere a unique phenomenon, or it appeared as a natural and logical result of long-term evolution? No wonder that the search for life beyond Earth represents one of the most important scientific directions. And in order to determine the most promising celestial bodies in this regard, was developed the so-called Earth Similarity Index, or ESI. It is based on two main parameters: the level of gravity on the surface of a celestial body and its equilibrium temperature. These are the parameters, according to scientists, determine how similar another world might be to Earth. And the conditions on its surface are favorable for hypothetical life. The undeniable advantage of ESI is its simplicity. After all, when an exoplanet is discovered, as a rule, its approximate orbit mass and size can be determined, and this data is just enough to calculate the main parameters of the index. However, for all its attractiveness, it does not take into account many factors critical to sustaining life. Therefore, we will formulate our own evaluation system, taking ESI as a basis and adding several important parameters to it. As one of them, the activity of the parent star can be distinguished. Frequent outbreaks and emissions are known. Stellar matter characteristic of red dwarfs may negatively affect stability, atmospheres, and radiation background of the exoplanets closest to them. However, red dwarfs are considered more favorable than large stars like Sirius or Vega because the lifespan of giant stars is too long, is small, and the radiation is too destructive, leaving no trace. Potential life chances for development. The most comfortable are considered to be orange and yellow dwarfs, including our Sun. Another significant factor can be considered: the probability of tidal capture, which depends from the distance between the exoplanet and the star. Celestial bodies located too close to the luminary find themselves constantly turned towards it with one side. As a result, a large temperature difference arises between their day and night hemispheres. Too great a distance from the source of heat and light takes the planet beyond its limits. Habitable zone, which sharply reduces its livability. It is also necessary to take into account the type and chemical composition of the exoplanet. After all, for the development of hypothetical life, a set of chemical elements combined with a characteristic relief. Similar conditions may provide rocky Earth-like planets or super-Earths, while mini-Neptunes do not possess solid surface, and ocean planets are deficient in many elements. Thus, the set of parameters we have collected allows us to comprehensively assess to what extent the conditions on the selected exoplanet are favorable for hypothetical life. For example, the land on such a scheme will look extremely attractive, being a natural standard for others, objects. At the same time, Mars Although it has the highest similarity index to our planet in the entire the solar system also has a number of obvious disadvantages. It is too cold and low mass, and also experiences significant water shortages. Venus, despite its external similarity to Earth, too hot due to the strong greenhouse effect. And although most of its parameters are in the green zone, extremely high temperature is a critical disadvantage of the planet, negating all its merits. Thus, there are no planets within the solar system, similar enough to Earth to be considered hospitable to life. However, for her, more than 100,000 galaxies have already been discovered near distant stars. 5,000th worlds, some of which, by many parameters, can be considered similar to ours. One of the closest such objects to us is an exoplanet, known as Gliese 1002b. It is located only 15.2 light-years away, years from our planet, and was discovered in 2022 using the radial velocity method. This method is effective for finding relatively close ones, exoplanets, and consists of recording barely noticeable fluctuations of the parent star, caused by the movement of space objects around it. The exoplanet is located near a small dim red dwarf known as Gliese 1002. Its radius is only 14% of the solar mass, and its mass is 8 times less than that of our star. Considering that the surface temperature of Gliese 1002 is only 3000 Kelvin, or about 2730 degrees Celsius, no wonder that its luminosity is extremely low, about 700 times less. Sunny. Also, observations show that the object is very different. Calm character unusual for stars of this class. Due to the low brightness of this red dwarf, its zone, habitability has an extremely small radius and width. However, the object Gliese 1002b is located near its outer edges and can be considered potentially habitable. According to observations, this celestial body is performing a complete revolution around the center of the system in about 10 Earth years, days from which it follows that the average radius of its orbit very small and amounts to about 0.0046 astronomical units. It is assumed that due to the extreme proximity to the exoplanet's parent star, most likely are in tidal lock and constantly turn towards him with one side. Calculations show that the celestial body receives from its star receives 1.5 times less energy than the Earth receives from the Sun, and its average temperature, surface temperature, can be approximately 230 Kelvin, or minus 43 degrees Celsius, which is slightly warmer than on Mars. Taking into account tidal capture and possible greenhouse effects. This means that on the surface of the exoplanet, liquid water may be detected, and therefore the conditions to sustain life, at least some terrestrial organisms are capable, survive in such conditions. Calculations also show that the mass of Gliese 1002b is 8% greater than that of our planet, and the radius exceeds that of the Earth by only 3%. Using these data, it is easy to determine the acceleration of free falls on the surface of a celestial body. It is practically no different from the meaning we are accustomed to. Thus, the combination of all the factors known to us allows us to assume that Gliese 1002b is a rocky planet, most of which is covered with ice. Due to its size close to Earth, it has enough high ESI equal to 0.86. On our diagram, this object will look like this. Thus, at the same time, climate modeling of the planet shows that its illuminated hemisphere can receive sufficient energy to support an ocean of liquid water with island archipelagos or even full-fledged continents. At the same time, tidal deformations from the side of a nearby star, the bowels of the planet are heated. due to which the existence of a hidden one cannot be ruled out. Under the ocean ice, even at night. Sighed. Moreover, Gliese 1002b is not the only planet in the system. At the same time, there was an object called Gliese 1002c was discovered located a little further away, namely at a distance, 0.074 astronomical units from the center. This exoplanet takes 21 minutes to complete a full annual rotation. Day, and its mass exceeds that of the Earth by approximately 36%. The object receives from the parent star at 4 times less energy than our planet receives from the Sun. Therefore, the temperature on its surface is low and is approximately 182 Kelvin or minus 91 degrees Celsius. If we use the previously developed scheme, then on it this exoplanet will look similar. It can be assumed that the conditions on the surface, Gliese 1002c, are close to those observed on satellites, Jupiter or Saturn. Increased volcanic activity caused by the mass of the planet can cause the emergence of an ocean with warm, salty water saturated with many chemical compounds. Hypothetically, in similar conditions, it may also arise. Life perhaps an extremely unusual and unexpected, for us in forms. Certainly, among the variety of known exoplanets, one can find much warmer and more comfortable worlds. Such is, for example, the planet K2-72I, located 217 light-years away from us. It orbits a small red dwarf, approximately 4 times less massive than our star. Its radius is 0.33 of the solar radius, and its temperature is relatively low and reaches 3360 Kelvin, or approximately 3100 degrees Celsius. Observations made by the orbital telescope. Kepler showed that the exoplanet crosses the disk of the mother planet, stars every 24 days. This means that the radius of its orbit is very small and is of the order of 0.1 astronomical units, from which it follows that the celestial body is located within the habitable zone and can be considered potentially viable. The data obtained also allow us to assume that K2-72I may be tidally locked or orbiting, resonance of the Mercury type. Despite the low luminosity of the star, exoplanets receive 11% more energy than the Earth receives from the Sun. If we assume that the atmosphere of K2-72I is similar to that of Earth, then the average, the temperature on its surface, should be approximately 295 Kelvin or 22 degrees Celsius, which is slightly warmer than on our planet. It is worth remembering that if a celestial body is in tidal lock, then the probability is high. Extreme temperature differences between the day and night hemispheres. In addition to this, it is worth take into account that his mother's light. Like most other red dwarfs, it is distinguished, fickle nature, and often demonstrates flares and large ejections of stellar matter, which can have a detrimental effect on the atmosphere and surface of nearby space objects. Meanwhile, calculations show that the K2-72I is 29% larger in diameter than Earth and approximately 2.2 times more massive. Knowing this, we can calculate the level of gravity on the surface of this celestial body. It is approximately 32% higher than what we are used to. Indicator. Thus, by combining all known data, we can assume that this exoplanet is highly likely to be a rocky super-Earth, where liquid water and a dense atmosphere may be found. Its similarity index is high and amounts to 0.87, and on our diagram these objects will look like this. Planets of this type are expected to exhibit a wide variety of morphologies, chemical elements, and a smooth relief favorable for the emergence of life. Sure, Frequent flares from a nearby star pose a significant threat to the atmosphere. However, a powerful magnetic field, hypothetically capable of deflecting particles of stellar wind, and the oceans to protect their inhabitants from harmful radiation. In this case, it can be assumed that on the K272I you can see incredible polar lights much more grandiose than those on our planet. As for hypothetical biosphere capable of developing on such a planet, then most likely it will be noticeable, differ from the earthly one. A different spectrum of incident light may force native plants to use alternative substances for photosynthesis, so their leaves are likely to will have purple or reddish color. In addition, excessive radiation hazard may limit the exit of life onto land or lead to the evolutionary formation of protective adaptations, for example, thick skin or specific cellular buildings. Similar features are also known in terrestrial organisms, for example, slugs, carhae, and some mushrooms. Meanwhile, in addition to this planet, which is attractive in many respects, 3 more have been discovered in the system. 2 of them, which received the indices K272b and K272c, are located very close to the parent star and slightly larger than our planet. Supposed that because of emissions and stellar wind, close luminary, they are devoid of atmosphere and are similar to the third planet. K272d is estimated to be comparable in size to the Earth, and its orbit has a radius about 0.08 astronomical units. It makes a complete revolution around the center of the system in approximately 15 days and is located near the inner edge of the habitable zone. Due to the high temperature conditions on the surfaces are most likely approaching those of Venus, and the probability of the origin of life is extremely small. In any case, research into this system is still ongoing, which means we have a lot to learn about her in the future. Meanwhile, all the objects we examined were close in size to the Earth. However, life as we know can adapt to a wide variety of conditions, including high gravity, which is inevitable on massive planets. If we move away from the solar system by about 1800 light-years, we will be able to detect a yellow dwarf. In its parameters, it is very similar to our Sun. It was named Kepler-452 and is a star. The main sequence is only 3.7% more massive and 11% larger than the Sun. In 2015, near this, a very remarkable feature was discovered using the transit method. Exoplanet named Kepler-452b. Highly accurate measurements made it possible to calculate that it is at a distance of 1.04 astronomical units from the center of the system and makes full annual turnover in 385 days. This arrangement makes tidal capture likely. The celestial body is extremely low, which is undoubtedly a favorable factor. According to available data, Kepler-452b is approximately 5 times more massive than our planet, and its radius is approximately 1.5 times larger than the Earth's. This means that the acceleration of free fall on the surface of a given celestial body 2.2 times higher than the indicator we are used to. Such a high level of gravity most likely helps the planet to maintain a dense atmosphere and also smooth out its relief, which can cause the emergence of many shallow and warm seas. It is believed that these conditions are the most favorable for the potential origin of life, but for humans, such a significant attraction will prove to be extremely uncomfortable. It is also known that Kepler-452b receives 10% more energy from its parent star than the Earth is from the Sun in its habitable zone. Calculations show that the average surface temperature, the object is about 300 kelvins or plus 27 degrees Celsius, which is 11 degrees more than of our planet, which means that the climate of Kepler-452b may be close to that. That was in the Earth's Mesozoic. However, given a certain atmospheric composition, such a temperature can be dangerous and lead to the acceleration of an irreversible greenhouse effect up to the complete evaporation of the oceans. According to some hypotheses, this is exactly the process that took place several billion years ago, radically changed the appearance of Venus. From the totality of all the factors known to us, we can assume that Kepler-452b is most likely a rocky super-Earth, rich in a wide variety elements and minerals. It is assumed that due to the increased content of radioactive elements, planets of this type should exhibit increased volcanic and tectonic activity. Activity in high gravity prevents the occurrence, extremely high mountains and deep faults. At the same time, the ratio of land to ocean on the surface, Kepler-452b must be different than on Earth. Therefore, this exoplanet has a high probability, may represent a vast ocean dotted with a scattering of archipelagos. If we move away from dry numbers and try to imagine what life might look like on this amazing planet, so similar to Earth and at the same time so different from it in many ways, then a truly fantastic spectacle will appear before us. Probable abundance of shallow, warm seas allows us to expect a wide variety of aquatic life forms, from the smallest to the very impressive. As for the land creatures, they are more likely, in total, will be represented by stocky trees, with thick trunks and creeping herbaceous plants, due to the fact that the spectrum of the parent star in the system, close to solar color of photosynthetic parts. Local plants will most likely be familiar, for us, green or bluish. You can also expect to see a variety of small animals, strong bones and strong muscles. Another path of development is creatures with an external skeleton, similar to terrestrial arthropods. As for flying creatures, here are the opinions of exobiologists are separated. Some believe that high gravity will be an insurmountable obstacle for flight. Others suggest that the high density of the atmosphere will be decisive, a favorable factor in this matter. In any case, we still have many years of research ahead of us before we can say with certainty that the planet is indeed habitable. Every year we discover hundreds of new exoplanets. Some of them are completely unfriendly and even dangerous. Others are similar to Earth in many ways, but no matter how much we observe other worlds, we still are unable to reach them. The Earth remains our only home, and we must use it, every opportunity to save it. Every step along the path of progress leaves a scar on the face of our home planet, and it is hardly possible to say for sure when these changes become irreversible. And let's hear each other.